Hey everyone, I'm going to go over a couple of things that I think you'll need some help with on 18.2 notes. So these are reversible reactions in equilibrium. As you come down here, this one where it says the middle one, just go to the next slide and you'll see that there's a middle one. And that's where both types of reactions or molecules are present, not reactions, just molecules. And that's equilibrium. And then I think we're okay on the first page. So go to the second page, and we're going to go down to equilibrium constant. So right here, what does the value of KEQ? So EQ means equilibrium, K means constant. Tell about the equilibrium position of a reaction. So this constant is a number that we use, and we actually use numbers. We use moles. So there's good old moles again. Here's a reaction, and then you're going to put this into an equilibrium expression, is what we say. So the reactants go on the bottom, and they have brackets around them. So we'll do A and B. So those are brackets. And let's say you have a coefficient here. So on this it says 2A. So on 2A, we're going to do an exponent of 2. So if this was 0.1, we would say 0.1 times 0.1 for that one. And that's with just coefficients, not subscripts. On the top are your products. So we'll do concentration of C times the concentration of D. And that's how we set that up. Then if we go down to the sample problem, it actually puts numbers in for us. So let's write our equation first. So we've got KEQ is equal to, remember the reactants go on the bottom, so that's N2O4 goes on the bottom. And then here we have a coefficient. So this is 2NO2 on the top. So NO2, and then there's a 2 here. Okay, so that's our equilibrium expression. Now we're going to put numbers in for these. So our question here says a liter of gas mixture at equilibrium is at 10 degrees Celsius, and it contains 0.0045 moles of N2O4. So that's going to be the one on the bottom. And then 0.030 moles of NO2. That's going to be the one on the top, and we're going to square it. So now we're going to write the expression and then solve. So we'll write another line here, and we'll put 0.030 in here, and we're going to square that. And then we're going to take 0.0045 and put it on the bottom. So let's get our calculator out. So 0.03 times 0.03, so that's 0.3 multiplied. So we've got 9 times 10 to the minus 4th divided by 0.0045, and that gives us 0.2. So our answer is 0.2. And then the question could ask us, and the molarity cancel, or the moles cancel out, so it's just 0.2. So if we come up here, KEQ is greater than 1 means that your products are favored. And if the KEQ is less than 1, it means reactants are favored. And so if we come down here, 0.3 multiplied is 0.0009. So that becomes a much smaller number. And then this on the top is the reactant. So we're less than 1, so that means the reactants are favored. And the question may or may not ask you for that. So that means at this temperature, in this situation, your reactant, your equilibrium is going to be a little bit on the reactant side. You'll have more reactants in the equilibrium. So we'll do a few more of these. I'm probably not going to put them on the test because we're not all together. So, but for those of you who are going on and like chemistry and have done really well, you'll want to know this because it'll be important in classes in the future. So anyway, hope you guys are doing well, and hopefully we'll see you soon. Bye.